Good morning, good afternoon, or good evening. This is going to be a full work through of the January 2019 3HR iGCSE paper. As always, please only use these videos as guidance once you have already attempted the paper yourself. Using this before you've had a good go at each question removes the value of doing the questions and trying to find the patterns and the insight yourself. As always, read the front of the paper carefully. Remind yourself that we have our calculator. We should be putting answers on the answer line, etc. Formula page, as always, should always be referred to double check that you've quoted any formulas later on in the paper correctly. Being very familiar with this sheet will save you a lot of time later into the paper. Let's start with question 1. We have percentages. Pierre's weekly pay is 560 and he's getting a pay increase. Well, a pay increase, we add it on to 100%, so our multiplier is 1.07. So my new weekly wage is my 560 multiplied by that value. 560 times 1.07 gives me an answer. And of course, as money, we should always be giving it to 2 decimal places. Another character also gets a pay rise. This time we've been told the final result rather than the initial. So we wish to go backwards. It's the same multiplier. Don't fall into the trap that the opposite of an increase is a decrease. Still a multiplier of 1.07, but we're dividing this time 1.07 divided by 42 divided by 1.07. A much less pleasant number, but again we're just going to round it to 2 decimal places, as is money. Question 2. The diagram shows 2 circles, each with a diameter inside of a rectangle. We want the shaded region. Well, let's find the area of the entire rectangle and subtract off the 2 circles. So we're going to subtract 2 lots of pi. Well, the radius is what we need in pi r squared, so 2 lots of 15 squared. Now I'm expecting the answer to be quite close to the entire rectangle. Those circles both look relatively small. An answer of 4,636. Then round our answer to 3 sig figs centimeters squared. That seemed reasonable. This was roughly 100 by 50, so roughly 5,000. Well, quite a bit more than 5,000 for just the rectangle. So around 4,500 seems reasonable. Question 3. We have a spinner. We have most of the probabilities. We want the probability of it landing on white. Well, that's recalling the fact that the total probability in any situation is 1. So I do 1, take away all the other probabilities. I'll find out the last option. And trusty calculator says 0.45. We're now going to spin it a very large number of times, 360 times. We want the estimate for the number of times it will land on red. For any of these estimates, these relative frequencies, the number of times multiplied by the probability gives you how many we'd expect. Probability of red being 0.1 in this situation. Question 4, our transformations. We wish to enlarge shape A with the center of the origin. Well, that means we're counting from the origin to find our new spots. So I'm going to go to the tip there. That was 1 to the right, 2 up. Scale factor 3 is going to be 3 to the right and 2, 4, 6 up. So the new tip is going to be there. Now I can build the shape from this tip. Going along there was diagonally backwards and up by 1. It's going to be diagonally back up by 3. 1 to the right becomes 3 to the right. 2 down becomes 6 down. 1 to the left becomes 3, and then diagonally back to where we started. Question didn't tell us to label it as anything, so I'm sorted. Next up, we're going to describe the single transformation from B onto C. So I'm going that way. It's not a translate, it's not a reflect, it's not an enlargement, which leaves behind a rotation. If I'm going that way round, I can go 90 degrees anti-clockwise. Now I need to find the center, and these are always a bit challenging to find the center. Excuse me. And it appears that there would be the center. Diagonally that way seems to make it work. Of course, you can check that with tracing paper in your real exam. So this is about 1, -1. Question 5, express 630 as a product of prime factors. 630. Lots of ways to split this. Let's go 63 and 10. Let's then split further. 63 becomes 7 times 9. 7 is prime, circle it. Split up the 9. And then 10 over here is 5 and 2. I've now finished my prime factor tree. So I now need to just collect it all together. As so. Notice I've collected the 2 3's together to make a 3 squared. We are now going to plot a graph, plot a quadratic. First, our table of values. We're just going to sub those coordinates into the formula. Be very careful when we sub in -1. We should be subbing it in brackets to ensure the calculator does exactly what we want the calculator to do. That comes out as 2. Subbing 0 in, that's -1. Subbing 3 in, and then finally subbing 4 in. We get all of our coordinates that we require. Now we're going to plot all of these points. So at -1 we're up at 2, 0 we're at -1. Notice the slight symmetry that we have. Being a quadratic, we are expecting this U shape, and quite nicely we can see that the U shape symmetry comes out quite clearly. Again, with you and your pencil, you'll be able to get through all the points a little easier than I can on the iPad. Finally, we want to solve the equation where this quadratic, and to double check that it is the same on both sides, equals 1. So I'm going to draw that line on my picture. We want to find the solutions. We want the x solutions. So we've got a solution there, which appears to be about 2.6. The solution there, which is -0.8. You do get some leniency. Of course, your answers might be slightly different from mine if you've drawn the graph slightly nicer than I managed. Question 7, we have a pentagon and lots of algebra hidden inside the pentagon. So the fact we need to remember here is the total angle. So total in a pentagon, well, our formula is n minus 2 times 180. So that's 3 times 180, 540. So if I add up each of these angles, I will get 540. Well, that's going to be an equation which we can set up and solve. So let's add all of our angles together. I start at the top and then go round clockwise to make sure I don't miss anything. equals 540. Let's collect all the like terms. I've got a 2x, a 3x and a 3x, that makes 8x. I've got a 37, a 90, a 130 and a minus 5. 252 equals 540. Subtracting 252 gives me my 8x is 288, and therefore x by dividing by 8 is a nice clean 36. Double check the question. We did what the question wanted. We did find the value of x. Be careful, sometimes these questions can ask for the smallest angle rather than the value of x. You've got that one extra step to deal with. Ben, Carlos and Delena share in a ratio. Ben is giving half his money to charity, Carlos gives 2/3 to charity, and Delena gives 30% to charity. So first let's actually share in that ratio. There are 10 parts in total, so one part is 76, and then let's just look at them each in turn. Ben gets 2 parts, so 2 lots of the 76, so he's getting 152, and he gives half of that to charity. Well, it was a bit pointless times it by 2 because I'm going to divide by 2 again. So he gives 76 to charity. Next up, let's look at Carlos. He's getting 3 lots of 76. And again, I'm already noticing that I'm going to be undoing this 3 lots of a little bit. So I'm giving 2/3 of that, so 2/3 of this 288 is going to be given to charity. I am just doing it into the calculator to ensure I am getting the right values and not trusting mental arithmetic too much. So that's another 152 to charity, and then 30% for our final section. So here we get 5 lots of 76, which is 380. 30% of that, so that's 0.3 lots of, times that by 0.3 gives another 114 to charity. So total to charity, the 76 from Ben, the 152 from Carlos, and the 114. Let's type all those in, and let's make sure we're using the right currency. We're giving 342. Now it's worth just, as with every question, checking whether it seems reasonable. We had 760 to start with. Ben's giving about a half, Carlos a bit more than half, Delena a little less than a half. So about half of 760 is where our answer should be, which is indeed around the 340 mark. Our algebra / indices question. Dividing, we subtract the powers. 5y divided by y. You can imagine there's little hidden powers of 1 on both of these, or write it as a fraction and the y's just cancel. Expand and simplify. 4 lots of each of those things, and then minus 2 lots of each of those. Notice that there is that minus 1 in front of the y because it was minus 2 lots of. Collecting like terms, again being careful with the negative y's. 2x minus 14y. Straight line is passing through a point and is parallel to another straight line. Parallel has the same gradient. The gradient I'm going to be using here is -3, from the -3 hidden in front of the x for my second line. It's going through a point with those coordinates, so we need to sub those into our y equals, well, it was mx plus c, but we know what m is, so we're going to sub in 6, -4, so So negative 4 is negative 3 lots of 6 plus c. That's negative 18. Negative 4 plus 18 is 14. So y is 14 minus 3x. I've written it that way around. We prefer to have the start with a positive number. To double check, I can sub 6 into that and see if I do get negative 4 out, just to confirm that I haven't done any silly arithmetic. To question 11, standard form. Write that number in standard form. Well, the number between 1 and 10 which is useful is 5.4. How far did the decimal place move? It's 3, 4, 5, 6, 7. It's a small number, so negative 7. Population of Sweden is Denmark is 57.6%. So the population of Denmark is going to be our Swedish population, and then to find 57.6%, I'm going to multiply by 0.576 in my calculator, using the times 10 to the power button to make it easier to type this in. We're getting a horrible non-standard form number. Question wants it in standard form to 2 sig fig, so I use 5.7, and then it's 1, 2, 3, 4, 5, 6. And again, just check that we haven't done anything stupid. Population of Denmark is about a half of Sweden, so you shouldn't expect the power 10 to the 6 to change. China is, Hong Kong is. The population of China is k times the population of Hong Kong. So that's 1.4 times 10 to the 9 is k lots of 7.4 times 10 to the 6. We want the value of k. So we are doing a division. I'm writing this out in full to make sure that I get that method mark, even if I somehow typo into my calculator. If we don't write that bit, and we do get it wrong, for whatever reason, then it'll be pointless to lose that mark. And we wanted it to the nearest whole number, so let's round off after the 9. Question 12, simultaneous equations. Now it is up to you whether you get rid of the x's or the y's. I'm going to choose to get rid of the y's because they're opposite signs. That means that I can add to kill them, and adding is just a little bit nicer than subtracting. However, they are two different numbers, so I'm going to have to multiply both of them. Trick is to multiply by the opposite coefficient times the top one by 3. 5.5 times 3, I'm going to make sure that I'm not going to make a mistake. Type that into my calculator. 16.5 times the bottom one by 2 equals negative 26. Notice I've times every single part. It's very easy to forget to times the numbers on the end. Now the y's have the same coefficient but with opposite signs, so I'm going to add them. I'm a little cautious because these are not pleasant numbers, and that might be unpleasant. I'm dividing by 19, but my calculus tells me not to worry at all, and it comes out as negative a half, quite clean actually. I now need to find y. I'm going to sub it back into the first equation. 3 lots of negative a half now, plus 2y is 5.5, so 2y, that's negative 1.5, so I'm adding on 1.5 to eliminate it, equals 7, so y is 3.5. I have my two values. Lovely thing about simultaneous equations is if I sub those into the other equation, if I sub it into the second one, and my answer works, then I know I've done the question correctly. And a quick check in my calculator does indeed show the second one subbed in comes to negative 13. I know I've got that question correct. Question 13. This is coming to around the middle of the paper. And the first half we're looking to be as consistent as possible for the grades 6 and 7. Second half of the paper is where it gets a bit more challenging for those higher grades. Table shows the information gained by 200 students. I'm going to keep that in my mind. Knowing the total is always helpful. We want the cumulative frequency table. Well, that's our running total. From 0 to 20 we've only got 15. From 0 to 40 we've got the 15 and the 25. Then we've got an extra 80 to go up to 60, an extra 50, extra 20. And then finally the extra 10. I'm happy because I've got to 200 at the end, and I was told there was 200 in total. So I haven't made some simple arithmetic slip. Now unfortunately, because it's on the iPad, I need to swipe, but hopefully this will be over a double page. We now need to plot. First one to plot is the 2015. So a mark of 20 with a frequency of 15. It appears that each of these squares are 2 each. So to get 15, we're going to go in between some values. For 40, we're at 40. Some nice symmetry there. I apologise for the jarring zooming in and out. It's the only way to get it accurate. 60 to 120. So 60 is down there, 120 is up here. A big jump there in the middle. 80 as at 170. So 80 all the way down there up to 170. 100 at 190, and then 120 at 200 right at the top. Join these together. Now you don't have to start at 0, 0, but you do have to join them with a nice smooth curve. Again, yours might look better than mine with pencil on a real paper. 200 students. Okay, use your graph to find an estimate for the median. Median, well, that's halfway up, so we're looking at 100. So we're going to go across at 100, and then we're going to go down from there. I'm noticing along the bottom as well, it appears to be going up in 2s. So that's one small bar off the 60, so our median is about 58. Graph to estimate the number of students who gain more than 75 marks. Well, 75 down at the bottom, that's going to be quite an awkward section, because there's 70, so 75 is kind of halfway through the next 2 bars, and I wiggled a bit there, and then we need to go across the graph, across the y-axis. Now that appears to be 62, 63 is what I'm going to go for, but that 63 was the number of people who got less than 75 marks. Cumulative is all about less than, so that is less than 75. Gosh, that less than symbol did not agree with me. Well, if there are 175, nope, I put the 100 in the wrong place. And let's also go back to purple for consistency. Less than 75 was what we were looking for. Our graph told that was 163. There were 200 people in total, so subtract off the 163. It says that 37 people, roughly, took less than that. Of course, with any of these from the graph, you do get a slight range for your correct answers. Back to algebra. We have an algebraic fraction question. I don't like fractions if I can help it, certainly in my equations. So I want to eliminate the over 3 and over 7. Best way is to multiply by 21. When I multiply the first fraction by 21, the 7 cancels, the 3 is left behind. When I times the second fraction, the 3 cancels, the 7 is left behind. And I need to remember to multiply this side as well. Notice I did just kind of multiply up opposites If you only remember that, then you may forget to multiply the other side, so be aware. Multiplying out our brackets, this is very similar to a much earlier question where we expanded and simplified. Collecting like terms, I've got 20w. I've also got a -9 and a -35, which I'm going to put to the other side. So I'm going to add both of those on, so that's an add 44. That's 68. Divide through by 20. And I get my answer of 4.3. Once again, it's worth subbing that back into the original question to double check you've got it right. Make E the subject. T equals the square root of a load of stuff. First thing we need to do is get rid of the square root. So we're going to square both sides. T squared equals that fraction. Notice on the right, the squared killed the square root. Multiplying up, if we can help it, we should avoid fractions. Now we've got brackets, let's get rid of those. I now have e's on both sides. I don't particularly like that, so I'm going to bring the 3e over and put the 3t back on the other side. So now my left hand side has e's, my right hand side does not. Factorize the e. And finally divide. I've lost a squared somewhere. That was careless. It should be 3t squared, 3t squared, all the way down. And having that mental check, that was me knowing that the only way that t appeared was as t squared. My answer line had a t, not a t squared somewhere, so I knew I'd lost the squared somewhere in my working. Very challenging but very productive checking technique to be constantly aware of what you have. Question 15. Henry has coins in a bag. We have some information on the probability that both coins are 5p's. Well, I could write out a full probability tree diagram. For this, I'm probably okay just to do 5p, 5p. Probability the first coin was a 5p, 5 out of 8. And the second coin needs to be a 5p. Well, there's only 4 5p's left. There are only 7 coins left in the bag. Multiplying and simplifying our probability gives us 5 over 14. Find the probability is at least 6p. Well, that seems quite challenging. There's a lot of possibilities in a 5p, 2p, 5p, 5p, or 5p, 1p. I've already done the 5p, 5p. So let's look at the others. So it could be 5p, 1p, or the other way round, 1p, 5p. These will both end up being the same. 5 out of 8. There's only 1 pence. So that's 1 out of 7. Other way round would have been 1 out of 8, 5 out of 7. Notice the numerators are just swapped over. I am going to keep track of each of these as we go. Other possibility was 5p, then 2p, 5 out of 8, then 2 out of 7. Leave the denominator out of 56. I know that one cancels, but when I combine these later, that'll be helpful. Other way round gives the same figure. Numerators are in the opposite order. Make sure that looks like a 56, not a 36. And then we also had the 5p, 5p variant, and there's only one of those, and that was 20 over 56. So those are all my possibilities to get at least 6p. Let's just double check. I couldn't do a 2p's. I had to have at least one 5p. So we need to add all those up. These are all the different possibilities. We're saying or in between each one. And I can cheat a bit in my calculator. I can just add all the numerators instead of adding each fraction. So that's 50 over 56. Let's simplify that a little. 25 over 28. Am I surprised that that number's so close to 1? Not really. There are a lot of 5p's and very few of the others. On reflection, it might have been easier to find the probability of being less than 6p, and then doing 1 take away that probability. There would have been fewer choices to deal with in that case. Proportionality. P is directly proportional to the cube of W. P fish W cubed. Fish becomes equals K. We've got some values, so let's sub them in. I haven't even read what the question wants me to do, but these questions are all very, very similar every single time. So K is 337.5 over 125. That's going to simplify a lot, but I'm going to do that in my calculator. So that was 0.3. The question wanted a formula for P in terms of W. So I need to have P and W both in that formula, but not K. Calculate the value of P when W is 4. And now I just sub it in. 0.3 times 4 cubed. In my calculator, 0.3 times 4 cubed comes out as 19.2. Nice simple question. Proportionality is often very similar every time. Simplify. That cubed has to hit each part separately. So we're getting a 5 cubed, 125. H to the 4/3 cubed, we multiply the powers. The over 3 and the times by 3 cancel. And then finally g squared cubed, multiply the powers once more. 18. Functions. Relatively early for a function question, question 18. Find g f of 7. So that's g of f of 7. Well, let's sub 7 into what f tells us to do, which is 3 lots of the 7 over 4 minus 7. And I could try and work that out. There's a few things that cancel nicely. I'm just going to type it all into my calculator to make sure I don't do anything silly. That comes out as negative 7. G then tells us, I don't need the G brackets now because I'm using G. So putting minus 7 is 2 lots of minus 7 plus 1 over 3. Unfortunately, I don't think this comes out particularly nicely, although it's awfully close to being. So that's negative 13 over 3. Just going to double check I didn't do anything silly with changing my values. Sub 7 in, then sub negative 7 in. Yeah, not a particularly pleasant number, which is why I did that double check, but not impossible either. Inverse function. Inverse function, we set the thing equal to y, rearrange to get x as subject. A lot of people prefer to swap x and y early. It doesn't make a difference when you do the swap, as long as the swap happens. And here is where the swap's going to happen for me. So g inverse of x, I'm not going to write 3y, because I have to be in terms of x, so I've swapped the x and the y there. 3x minus 1 over 2. Find fg of x. Notice this is a different order from the first part, and we're in terms of x. So this is f of, well, g was 2x plus 1 over 3. Now I'm already expecting a fraction in a fraction. This is what I have to replace x by in the formula. So x is the whole of 2x plus 1 over 3 over 4 minus 2x plus 1 over 3. Really quite an unpleasant thing to now try and deal with. In particular, we've got fractions inside fractions. Best way to deal with that is times top and bottom by the denominator. So I'm going to times top and bottom by 3. On the top, that kills the over 3. On the denominator, that kills the over 3. Notice I have to put that in a bracket. I'm subtracting that off. If you lose that bracket, you lose the sign change on that plus 1. Expanding numerator, expanding denominator, cleaning up, minus 2x plus 3. I could have wrote that the other way around as 3 minus 2x, would have looked slightly nicer. Both are the same. Looking for any common factors. 3 is common to the top, but 3 is not common to the minus 2x, so I can't cancel that. If I were to factorise the top, I get a 2x plus 1 as my other factor, which isn't the same as the denominator either. So that is, unfortunately, as simple as it can be. Question 19 appears to be our 3D trig question. We have a rectangular based pyramid. We have the slanted sides are all 12, 15 and 10 on the denominator. I want the angle CEA. Now this is an unusual one. So we want the angle up at the top of that triangle. Well, I already know two sides of that triangle, but it's not right angled. So that's telling me it's not SOHCAHTOA, but it's end up going to be cosine rule to find that angle. So if I can find the diagonal along the bottom, I'll be in a really good spot. We'll cut in that base in half with the triangle CBA. We have 15 centimeters, 10 centimeters, and this is right angled because it's a rectangular base using Pythagoras, square root. So we're looking for the longest side, the sum of the other two squareds. And again, typing this into my calculator to ensure I don't make any silly errors. And I'm going to also leave the answer exact so I don't get rounding errors, is 5 root 13. Now I can use the triangle that I actually care about, which had sides of 12, 12, and 5 root 13. I'm going to put the labels to make sure the examiner knows where those where the triangle has come from. And the angle I want is up there, which I'm going to give a name as well, theta. Now from the front page we have the cosine rule, but unfortunately not the rearranged version. And all of our sides are angles are labelled differently than the A, B and C. Now you can just memorize the rearrangement, or you can do it yourself each time. But that is how it rearranges. And notice the important part is the angle that we care about. That's quite a dark highlighter. Let's swap to a brighter version. The angle that you want is the subtraction, the subtracted square in the top. So you don't really need to relabel if you notice that. So apply to our triangle, cos theta is 12 squared plus 12 squared minus the opposite side squared, 5 root 13 squared, all over 2 times 12 times 12. And yes, indeed, I did make sure that I put those as the opposite pair. Into my calculator, a very unpleasant fraction. Hint when doing these large calculations is to hit the fraction button first so that you can type everything into the top and then move down to the bottom. That fraction comes out as incredibly unpleasant, negative 37 over 288. Cos inverse of that answer gives me an angle of 97 rounded to 1 dp, 0.4. And again, we can get some interpretation of this. Were we expecting that angle at the top to be obtuse? Yeah, it appears so. The base is very large. The slanted height isn't that long. So this is quite a short, stubby pyramid rather than a tall, sharp one. So an obtuse angle at the top seems reasonable. Vectors. AOB is a triangle. OA is 3A. It's not labelled in the picture, so I'm going to label it myself. O to B is 3B. And O to C is 4/3 of that. Well, that means O to C is 4B. So B to C is an extra B. Q is the point on AC. Now these aren't labelled on for us yet, such that AQ is 3/5. So Q is somewhere along here, such that that is 3/5. Well, that's split it into a ratio of 2 to 3. And P is on AB, such that a BA, such that B to P is 1/3 of B to A. That's a ratio of 1 to 2. It's slightly easier with vectors, certainly on the picture, to have these ratios. Using a vector method, prove that OPQ is a straight line. Now, the method of proof here, and our kind of plan, is we're going to find both OP and PQ, and if they formed a straight line, then these are just, I said OQ. Let's try and find OP, and I think OQ is slightly nicer than PQ. And if these are multiples of one another, OP is maybe half of OQ, but in the same direction, then these have to be a straight line. So that's our method of approach. Well, we actually need to do that now. Let's try and think about O to P. Well, to get from O to P, it's probably easier to go from O to B and then B to P. Well, to go from B to P, I need B to A. So let's work out B to A first. Well, that's going backwards, and you go B to O, and then O to A. B to O is the opposite direction of O to B, so that's the O to A, but we're going backwards, so it's minus 3B, not plus 3B. So O to P is O to B plus B to P. O to B is 3B plus 1/3 of that one we just worked out, using the fact from the question that B to P is 1/3 of. 1/3 of that gives us just a singular A minus, plus 3B minus a B to B. So that's O to P. I'm going to keep that for later. I need to now basically do exactly the same thing, but for O to Q. Now O to Q, I can go via C or I can go via A. I'm actually going to go via A because that's the direction where this relationship is written. So let's first find A to C. Well, A to C has to be A to O plus O to C. A to O is negative 3A. O to B is 4B, as already noted when we were labeling our diagram. Then O to Q is O to A plus A to Q. O to A is 3A plus, well, now it's A to Q is 3/5 of AC, hence why we worked out AC. Using that fact up there. Numbers this time aren't going to be quite so pleasant, so I'm going to trust on my calculator for this one. The A's, I've got 3 of them, and I'm subtracting off 3/5 of 3 of them, which gives me 6/5 of A plus 3/5 of 4B, that's 12 over 5B. And now for the magic. I've got both of them, but I need to show that they're the same direction. For vectors to show they're the same direction is to show they're simply a multiple of one another. Factoring out from this one, if I factor out 6/5, I get A plus, or 12/5 factored out by 6/5 is 2B. Oh look, there's the A plus 2B that we had up here. So that's 6/5 of OP. So what have we shown? We've shown that OQ is 6/5 of OP, which means OQ and OP are parallel. And the only way those to be parallel and to share O means that OPQ is a straight line. Very challenging vector proof there, but quite a standard technique to show things lie on a straight line. Question 21. A right-angled triangle with a load of algebra. The area is A. Well, that's going to be challenging to do if I don't know what the side lengths are. So I'm actually going to find X first. Now, the only other thing we know about right-angled triangles, which is always true, is Pythagoras. So I'm going to use Pythagoras here and hope that the algebra doesn't get too nasty. The sum of the squares on the shorter side is equal to the square of the longest side. Lots of double brackets to expand out. Don't fall into the trap of doing, oh, that undid a lot, of just squaring the x and squaring the 2. Make sure you remember your middle term. If you do need to write them out as actual double brackets, you should. Left hand side is done. Right hand side. And here, knowing your square numbers are quite high is quite helpful. Collecting together all the like terms, quadratics, we want them to be equal to 0. So I'm also going to subtract off a load of the left hand side as well. X squared, 4x squared, take off an x squared. This is 4x squared. I have 4x's, another 28x's, but then I lose the 28x's again. I've got 4, an extra 49, and subtract off the 196. This is negative 143. Now, does that factorize? Is a really difficult question. If you're unsure, you shouldn't try. This is probably formula worthy. However, I believe 143 is 11 times 13, and then 13 times 2 is 26, and if I subtract off 22, I get exactly what I want. As I said, it's probably worth using the formula there if you're not hyper confident with factorizing these harder versions. They give me two answers, negative 6.5 and 5.5. Side lengths have to be positive, so negative 6.5 is not a valid solution. It has to be 5.5. Well, I'm going to redraw the triangle now with that actual side length labelled properly instead of the algebraic. So if x is 5.5, this side is 7.5. Two lots of 5.5 plus 7 gives me this side down here is 18. And then 14 plus the 5.5 makes the other side 19.5. One reason I've done that is to make sure my triangle still makes sense. That hypotenuse should be the longest side, and if it wasn't, I'd have been quite worried with my calculation somewhere. The question actually wanted the area of the triangle. Area is half base times height. So a final simple calculation to get the job done, and my area is 67.5. Quite a difficult question, but on very simple concepts. Quadratics and Pythagoras are relatively, middle level difficulty for one of the last questions in the paper. Question 22 is our final question. We can see the total marks down at the bottom of the page. This again is based on quite an easy a middle level topic. Arcs and sectors. We have a sector with a centre and a radius 15. The arc length is 3 pi. We want to work out the area of the shaded segment. Well, area of the segment means we're going to have to do the sector, take away the triangle. Both of those require the angle first. So we need to undo the length of the arc to find the angle. Well, if we recall our arc length formula, is that angle over 360 times the entire circumference, which is 2 pi r or pi d, but we've been told that's 3 pi. We know r is also 15, so that's 2 pi theta times 15 over 360 is 3 pi. Pi's can cancel, I'm just going to cross them straight out. 2 times 15 over 360 is a 12, so theta over 12 is 3. So the angle is 36 degrees. Step 1. Step 2, we need to find the area of the sector and the area of the triangle. So I'm hoping I'll be able to do each half separately down here. So our sector, again another formula you need to remember, theta over 360, the fraction of the circle, times pi r squared. That's 36 over 360 times pi times 15 squared. When I type that into my calculator, I'm going to not type the pi in, because I don't really want my answer to look horrible. So just typing the numbers in is 45 over 2 pi, and I'll leave that exact for now. I'm going to make sure that my work is relatively well presented. Next up, we're going to try and do the triangle. Well, here we're needing to use the half AB sine C version. We don't have a right angle. So that's a half, or both A and B are the radius, sine of 36 being my angle. 0.5 times 15 times 15 times sine 36 is my angle as 66.1. And that number actually does go on for quite a while. So the segment, which is what the whole point of the question was, is the sector, that's the larger one, minus the triangle. And because I still have that answer stored in my calculator, I don't need to do any rounding whatsoever. 45 by 2 lots of pi. Subtract off that answer is my segment as 4.5599 ... Question wanted 1 dp, so 45.6 to 1 dp. Again, we're checking, does that number look roughly correct? Segments often are quite small. So with a side length of 15, having a very small segment less than 5 seems reasonable. If I got that as 46, I would have had to worry a little bit more. That was the last question in the paper. As always, if you spotted a mistake or you're unsure about anything, please do let me know. Otherwise, have a wonderful rest of your day.